All right, let's talk about what it really takes to build an AI product you can actually trust. It turns out it's less about some kind of magic and way more about this hidden, super fascinating engineering craft. So let's just dive right in. So, have you ever been using a chatbot and you just get this feeling that it's just not getting it? Like the vibe is totally off? Yeah, you are not alone. It's an incredibly common feeling, and it actually points to one of the biggest challenges in AI right now.
Exactly. The AI's response might be factually correct, sure, but the tone feels robotic, or it completely misses the point of what you were asking. It just feels weird. And look, this isn't just some small quirk. This is a fundamental, really hard engineering problem. Getting an AI to be not just right, but also appropriate for the situation, that's where the real work starts.
So let's start by really unpacking this whole vibe problem. Why is it so incredibly hard to get an AI to act the way we expect it to? Well, the answer comes down to a really core difference between these large language models and, the normal software we're all used to. This right here gets to the heart of it. Think about traditional software, like a calculator. It's deterministic. You put in 2 plus 2, you get 4, every single time. It's predictable. But LLM pipelines, they're probabilistic. They're based on statistics. The same question can give you slightly different answers. They're subjective. And as we just saw, that means they can be factually correct, but still completely wrong for the context. So how do you even begin to tackle this? Well, engineers have this really powerful framework for understanding these challenges. It's called the Three Gulfs model, and it's designed to help them pinpoint exactly where and why their AI pipelines are breaking down. And they're called the Three Gulfs for a reason, because they represent these massive, deep, challenging gaps that developers absolutely have to cross to get from a cool demo to a product that's actually reliable. We're not talking about solving one little problem here, but 3 huge, interconnected challenges that can derail a whole project. Okay, so the first one is the Gulf of Comprehension. This is about just understanding what the system is even doing under the hood. Where is it messing up? Then you've got the Gulf of Specification. Have we clearly, without any ambiguity, told the model what we want? Things that are totally obvious to us can be super confusing for an LLM. And finally, there's the big one, the Gulf of Generalization. Does our model take our instructions and apply them correctly to new situations it has never ever seen before? Okay, check out this brilliant example of a generalization failure. Imagine you're building an app that processes emails. The model sees the name Elon Musk mentioned in the body of an email, and it mistakenly pulls that out as a sender. Now, the prompt, extract the sender, was perfectly clear, but the model failed to generalize that rule correctly to this tricky edge case. That's not a prompting mistake. It's a generalization failure. So that's the problem space. Pretty big, right? How do engineers actually bridge these 3 massive gulfs? Well, the answer isn't just fiddling with prompts all day. It's a systematic, repeatable process, and it's called the engineer's lifecycle. This is really the core of the whole thing. It's a disciplined feedback loop that turns what feels like the chaotic art of writing prompts into an actual science. You analyze, you measure, and then you improve, and you do it again and again and again. So let's break this down. It all kicks off with the analyze phase. This is where engineers literally collect real-world examples of where the AI messed up, and they group those errors into specific categories. Then, once you know what's going wrong, you move to the measure phase. You turn those qualitative ideas like the tone is off into hard numbers you can actually track. And finally, you improve the system by making targeted changes to the prompts, the data, or even the whole pipeline, all to fix the specific issues you just found. That analyze phase is all about rolling up your sleeves and getting your hands dirty with the data. Engineers look at what the model is actually spitting out, and they start categorizing the problems. Is it a constraint violation, where it just ignored a direct order? Is it a factual inaccuracy, or is it that tone mismatch we talked about? See, by giving the problems a name, you can finally start to tame them. And one of the source authors, Hamill, puts it so perfectly and so bluntly. If you are not willing to look at some data manually, you're wasting your time with evals. The lesson here is so simple but so important. You can't just automate your way out of understanding your system's problems. It all starts with actually looking at the data. Okay, so once we've analyzed our failures, we need a way to measure them at scale. I mean, manually checking thousands of outputs is just impossible. So, how do engineers do it? Well, this is where it gets really, really interesting. They use a fascinating technique. They get other AIs to do the judging. You've got this classic trade-off, right? Human review is amazing for catching nuance, but it's incredibly slow, it's expensive, and it can be inconsistent. Automated review, on the other hand, is lightning fast, it can scale to millions of examples, and it's consistent. The real goal here is to build an automated system that has all those benefits, but also captures the nuance of a human reviewer. And this leads us to this really clever concept, the LLM as judge. The idea is you use a separate, specialized language model to act as a grader. Its only job is to evaluate the main AI's output against a super specific, usually binary rubric, like did it pass or fail on this one specific thing we care about. But, and this is a huge but, building a good judge isn't as simple as just telling an AI to go grade this. No way. It's a really rigorous engineering process. First, you have to write a crystal clear prompt that defines exactly what a pass and a fail looks like. Then, you use carefully labeled data to test and tweak that judge's prompt. And this is the really crucial part. You have to measure and sometimes even correct for the judge's own rate of error. And the standards for these judges are incredibly high. For an LLM judge to be considered truly reliable, teams are aiming for over 90% accuracy. And they measure that with two key stats: the true positive rate, or TPR, that's how well it correctly spots the good outputs, and the true negative rate, TNR, which is how well it correctly flags the failures. You need both of those to be super high before you can trust your automated measurements. So let's tie all of this together. We've analyzed our failures, we've built these automated AI judges to measure them. So how does this all come together in a professional software workflow? Well, it creates something called a continuous improvement flywheel. And this is where testing for LLMs looks really different from traditional software. Instead of trying to check against millions of possibilities, LLM testing focuses on these small, carefully curated golden datasets. These datasets represent the known, critical ways your model can fail. So the goal of the tests isn't to promise perfection, but to act as a safety net, to make sure you don't reintroduce problems you've already fixed. And all of this creates that flywheel. The system is live, out in the world, and online monitoring, using those very same LLMs as judge evaluators, is constantly watching for new unexpected failures. When it finds one, that new failure gets analyzed and an example of it gets added back into that golden data set, making the safety net stronger for the future. It's this awesome, virtuous cycle of improvement. So the next time you interact with an AI, just think about the incredible, hidden craft that's going on behind the scenes to make it reliable. It's not magic. It's this continuous cycle of analyzing, measuring, and improving. So knowing all of that, what does it take for you to truly trust an AI product? Thanks for joining us.